Okay. Hello, everyone. My name's Chris Murphy. I'm an evangelist for Epic Games, and today I'm going to be running you through an introductory session to virtual reality in Unreal Engine 4. Now, before I begin, can I get a quick show of hands of who here has worked with UE4 before? These two jokers at the back. Okay, so it seems like the majority of people have kind of like touched it at some stage. That's good. And of everyone else, who has worked with VR before in a development capacity? I mean, yeah, I can see some people who are like, well, you know, I slipped and fell and it ended up on my head, and then you've done the early stuff. So what I'm going to show you today is a quick run through on where to begin and how everything is kind of set up, and also the reasons behind why it's set up this way and how you can kind of use this to build whatever it is that you really want to build. Because it's kind of a short session, I've kind of taken the liberty of, of fast forwarding just a little bit. This on screen at the moment is Unreal Engine, and this is the screen that you would get if you were to open it up and click New Project and then select a VR project based out of Blueprint. Okay, so this would be the default template. Everything is stock. I haven't put in any additional bells and or whistles. This is just us kind of getting it all set up. Now, what I'm going to do from here is I'm going to quickly run through the first two things you can see. So what we have are two options for where we would actually use this template from. And a lot of the time, you know, people would sit there and they'd be like, well, VR, you know, you're wearing a headset. But there are two important templates that you can use to develop from. Now, the first one is HMD plus gamepad. So the first one is the one on the left. That represents if you were to do a VR project that was purely based out of a head-mounted display, where would you go with that? You know, where would you begin, et cetera, et cetera. Now, because that is something that people are becoming more and more familiar with, it's really just controlling the camera, that kind of discussion is best had with just generalized best practices, if you know what I mean. You don't need to be told so much how to set that one up. In Unreal, it automatically grabs your default camera and just sets your head to allow tracking for it as long as the checkbox is enabled. So for handling that, I'm actually not going to go into that today. Instead, I'll kind of go over the fun stuff. And we'll actually look at full room motion control and how that's set up and how you can develop from that. Now, the one on the right is that. So what we're looking at here is HMD plus motion controllers. Now for today, I should use the word recruited, but I kind of just told him he was doing this. I'm going to be using Jaden as our demonstrator, who's going to be up here. And hopefully I don't screw up anything too badly, or, you know, the front row end up as the soak seats. So we'll see how we go. But I'm going to initially load up this first level. And to do that, I'm going to go File, Open Level, and I'm going to open up the one that is Motion Controller Map, okay? So we launch into this, and you're greeted by this. Jaden, do you mind doing the honors? Cool. Okay, so within this world, you can see that we have a very, very, very basic level. Now, from here, we have just some basic cubes, as well as over here, you can see that there are these blue cubes. Groundbreaking stuff. So what we're going to do is we're going to fire into this, and when we first begin, we're going to launch from where this camera is on the ground. I'm going to hit play. Now, if you want to launch into VR, you just click on this arrow, and there's a little button that says VR Preview, okay? And upon doing so, it will launch you straight into it. Now, I've already selected it once before, so the default play style for this is now set to a VR camera. So whenever I hit play now, it will immediately launch into stereo. So I'm going to click that, and you can now see what Jaden sees on screen. Now, these are the default controls that we have within the template. So any project that you're developing immediately has the ability to leverage off of these with how they're functioning. So do you mind heading over towards the blue cubes for me? Thank you. Now you can see that the chaperone is automatically detected. Can you hold down teleport but not release to your right? So does everyone see how there's a rectangle being projected onto the ground? Now this refers to one of the states of locomotion that we can use. Now when it comes to locomotion within VR, there are a couple of different ways you can do it. People are still kind of working out what the best way to do it really is. In this situation, we just have the ability to teleport to any location. that is held within the navmesh. So I'll show you what that is in just a second. I'll try not to bust out too many tech terms without people being familiar with them. But you can see that this rectangle is kind of a weird thing for a teleport to have around it. But what this rectangle actually represents is the room. So ahead of time, I traced out where the region would be for this room, and then upon pressing the button, they can see where they would end up relative to the room itself. Do you get what I mean? I can see some people nodding, a couple of people go cross-eyed. What's wrong? So if he goes around and looks back at the cubes behind him, I'm making hand gestures that he can't see. If just like a cool, and you can use the triggers to pick up any of these boxes. So by default, we can just go out and grab another one. And if he wants, he can attempt to juggle, and we can test his coordination. Failed. But from here, we've got our basic props all set up. So he's able to interact with it. You can see that the hands have some basic motions as well, so that they're gripping whenever the triggers are pulled. And he can use this to do all sorts of things. For instance, he can pick up one of those boxes and put it on top of another box that he's holding to kind of stack them up a bit. Because they all just respond as physics objects. Okay, so the Unreal Physics Engine's just kind of kicking in and handling the load. Now, if I was to make a game that was straight up like Gone Home, for instance, and I wanted an interactable world, this is an entire grounding that you would need, that you would kind of start to develop those things with. Do you get where I'm coming from? He's starting to have too much fun, so I'm going to pull him out of VR, and we'll look at how this is actually set up, okay? What I'm going to do is, this over here is the player, and I'm going to right-click on it, and I'm going to hit Edit Motion Controller Pawn. Now, I could access from a couple of different locations. It's also stored inside of the Blueprints folder. I have a tendency to access things out of references in the world. Either way, it's going to launch the same screen, which in this case just loads up all of the code associated with the object on screen. Now, this is Blueprint. Can I get a quick show of hands of people that have used Blueprint before? That's really good. Okay, so for anyone that's unfamiliar with Blueprint, Blueprint is essentially a node-based coding language. So typically within Unreal Engine 3, so the previous version, development used to be done through two things. It used to be C++ if you were a licensee, and then you would have Unreal Script. Now with Unreal Engine 4, everyone has C++ access, but on top of that we use what is called Blueprint. And Blueprint is essentially Epic's attempt at making a very user-friendly interface, because it's basically developed to enable anyone within a development team to contribute in areas that they typically wouldn't be able to actually work with. A good example of this is, anyone in here a game designer or artist that doesn't typically program? A couple of people, hands are going up. So I imagine you've had these issues before where, have you ever had a conversation with your programmer where you're like, this will be a rad idea? And the programmer is like, yeah, maybe, but I got too much going on. Or maybe they just think it's a bad idea, so they don't want to test it. At which point you're like, well, I guess my feature's never going in this video game. Blueprint is great because it's made to be as accessible as possible. So what ends up happening is artists can kind of jump in there and start to tinker and work with things and just try out stuff. If you think that a camera shake is a good idea to have on landing and the programmer disagrees and doesn't want to put the camera shake in, you can just do it. And this is really, really useful because you can put in some pretty advanced behaviors in the process. So game designers can just experiment without having to go through their programming team. And in addition to that, you know, in this argument that I'm having with myself, I'm making the programmers seem like the bad guys. But the other thing here is that it enables the programmers to kind of focus on developing the stuff that matters. You know, you want your programmers focusing on core systems, and you don't want them having to go in and add the mesh to 30 different weapons that are being brought into the game and configure the values. You know, if your artists or your game developers, game designers are able to immediately jump in and tinker with those things, it frees up your programmers to kind of do what they want to do and what they really need to do. So with that said, let's have a quick look at how Blueprint functions, and then I'll run through the rest of this from there. So essentially we have an event-driven system. See these red nodes here? The screen reasonably clear for everyone? These red nodes represent events. So when an event is triggered, in this case begin play, so when the game first begins, this comes off and immediately just starts up a sequence that says, find out if they're using an Oculus, Steam VR, or PSVR, set it to the correct tracking origin that you would typically need to use one of these things, So does everyone understand how these white nodes represent execution flow? So it's just one instruction to the next instruction to the next instruction. There's no header information. You're not dealing with weird, complicated referencing and dereferencing of pointers. You're just kind of dealing with a conceptual level of, I need to do this, and then I need to do this. So we run through these steps. So this initially just sets it up for whichever form of VR you're using. So this demo is theoretically usable with either a touch setup or with PS VR. Still keep going to call that Morpheus. And from here we can then see that it goes ahead and does two other things, and this is very important. It creates a BP motion controller, and then it creates another motion controller. It attaches them to my body, and it sets one of them up to be left and one of them up to be right. Now, the reason I bring this up as pretty important is your body in this situation, in the VR demo, doesn't actually have hands until this point. The hands get kind of added to it, and they themselves have separate information that's being passed around, okay? So what that means is that your body can send basic input information through to your hands, but your hands can actually be separately programmed to be set up in whatever way you want. So if you don't want hands and you want to have gun hands, for instance, you could replace this reference and spawn in something else that would be that thing, okay? So if you didn't want to have just standard pickup work, you could have your right hand able to pick stuff up and your left hand is, someone give me a thing that's not a hand, sword. Yeah. So, you can set this up however you want. And from here, I'm going to have a quick look at how these motion controllers work, and I'll go into some of this functionality, and then we'll extend on it, and we'll go from there. So I'm going to open up the motion controller, which is the thing that we create. And it's got a bit of functionality that's in there, but for the most part, you don't really need to touch this unless you really, really want to. The functionality that is in there by default is rumbling whenever you're able to move to a location, so your hand gives you a nice, subtle hint that something is possible. There's hand teleportation that's built in there, so again, that's the teleport function that we showed you before, including the creation of a chaperone, so you can see where you're going to be relative to your space. We also have basic hand animation information is being held in there. That's a very simple blend that just tells the hand if it's open or closed, and Unreal's animation system automatically blends between an open and closed state. But for the most part, nothing here is particularly difficult. The thing that is most important for us to really look at is that when you use this, it's going ahead and it finds the nearest actor near your hand, and when you hit grip, the grip goes off and grabs the object. I'm suddenly not seeing the function. Grabbing, there we go. You can see that we have this function called grab actor, okay? Now, before I showed you events, and events are things that when they trigger, it goes off and outlines certain code that gets called. In this situation, a function is similar to an event with two big differences. An event can have like a delay in it if you want to. So it can say, run this, and 2 milliseconds later, run this as well. Whereas a function has what's called a return value. So a function could be run to give information to something else. So the function might be, check if my hand is near something. And it returns a value saying, yes, my hand is near something. Does that make sense to everyone? Wonderful. So in this situation, it gets the nearest actor near the hand, and it uses what we call an interface. And this is the real strength of this system, and this is the reason I'm kind of like running through these bits, is it looks for what's called a pickup interface, and then it runs that. Now, essentially when you're normally developing things, how you would typically handle it is you would have, for instance, a base actor that everything else that has those kind of instructions would be built from. So I might have, typically in a standard game, you might have a thing that was like my base pickup actor, and everything else would extend from that base pickup actor, so the ability to be picked up would be passed on to all of those things. Instead, what this does is it uses an interface, so that any object in the game can be given a special function that in Blueprint automatically says, hey, what should I do when someone tries to pick me up? What should I do when someone tries to release me? And I'll show you that on the prop itself. So I'm going to open this prop, one of these cubes in the world, which is this. And you can see that this prop itself has some events. For event pickup, all it says is, when I'm trying to get picked up, turn off my physics and attach it to the hand. So you can see that the attach to is the thing that gets read in from the hand that I showed you before. So when a hand goes to pick something up, it says to a prop, hey, this is me, I'm trying to pick you up. And the prop goes, okay, here's how that happens. And now what that means is, and again, for the drop function, all it's doing is it says stop simulating physics on this object and detach it from the actor. Now what this means is if I wanted to create something else, for instance, that when I grab it, it gives me different functionality, I could do that without any issue. So it doesn't actually need to be something that could be picked up. On grab, I might create a cable that is permanently attached to the wall that is following my hand around the room as I try and plug the other end of the cable into things. I might use the grab functionality as a way of, when I click on something, I'm actually activating it instead. Do you know what I mean? Like I could put this functionality in all sorts of weird and wonderful ways. But we can also extend on this further. So what I'm going to do is, at the moment these events pick up and drop, get read in from these input within the controller pawn. When grab left is called, it just passes the information to the hand to try and pick it up and see what happens. When released on your hand is called, it does that. Now, by default, this is using the triggers to pick things up, okay? So when I aim at something, I pull the trigger to pick something up. Now, does anyone think of what the issue is if you're using triggers as your way of picking things up?
When you let go, it's hard to hold the controller.
So, yeah, look, that's one thing. But one of the other big things here is that in a lot of games, when I pick something up, I probably want to do something with it. So when I pick up a gun, for instance, I want to fire it. When I pick up a flashlight, which probably would have been the friendlier example to have used, I want the light to have turned on and to turn off whenever I do it, okay? So typically input can be kind of a pain whenever you're working with a project. Has anyone here had these kind of issues when you're setting up inputs and things are going around? This is kind of one of the, another strong suit of Unreal. What I'm going to do is I'm going to go edit project settings. And I'm going to go ahead and I'm going to change this controller system around so that we are instead using the left and right grips as ways to pick things up, and triggers are instead going to call an activate function on them, okay? So I'm just going to extend this code just a little bit so you can see how to do that and how we would go about adding additional functionality to the game, okay? So the quickest way for me to do this, I've gone project settings. I'm then going to go down to this little section called input, okay? And under input, we have these two sections called action mappings and axis mappings. And if I click on these, you can see that a bunch of these have already been set up because these are by default in the template. And these are essentially just, you bind a generalized function that is grab left. And within here, I would actually say grab left is motion controller left trigger. And I could say grab right is motion controller right trigger. Does everyone see how that works? The fun part of this is you can add additional bindings, such as spacebar when they're not looking, so that the next time someone's like testing it, I can pick things up and they don't know why their hands are failing them.
Does this support the Oculus Touch?
Yes.
Like individual finger?
So how it works from here is all of those bindings, all of the bindings can be set straight up. I mean, so at the moment, Epic is developing Robo Recall, so that is explicitly made for the Oculus Touch. So any of the functionality you see in that is in Unreal Engine. A lot of the improvements as well are coming in the next version, which is currently in preview, but should be out in, I want to say, a few weeks. No, not sure the date. Yeah, a few weeks. November 11th, thanks. So from here, what we're going to look at is we've got grab left and grab right, and they're currently set to the trigger. What I'm going to go ahead and do is I'm going to rebind these to motion controller. I can see that I have grip, and I'm just going to bind it now so that we've got our grip set up as the things that grab. So I'm just going to select, again, our grip 1. So we've got left grip and right grip are now set up. So I've just quickly set that up. Jaden, do you want to jump it in? And these should now allow your players to cool. And now if he was to use the grips and untangle himself. I gave one of these presentations once, and unfortunately the cable got ripped out, so this entire time he's doing it, I have like got sweaty palms going on, just ready to dive and grab it. So you can see that now, instead of pressing the triggers, he's able to press the grips, and we get that functionality being pushed through instead, okay? Not exactly groundbreaking, but let's actually push that a bit further and now add functionality to the objects that are in our hands, okay? So I'm going to go ahead and I'm going to say, we have, you know what, you might as well just leave it on. This won't be too long. Plus this way everyone can look at you and judge your idle behavior. Okay, so I'm going to go ahead and I'm going to make a new thing that is called activate left and activate right, okay? and I'm going to bind it to the appropriate controls. It's also all contextual, so anytime I want to add one of these, you can see that it's filtering the results until it finds what I want to use. Cool. So we've now added two functions here that are just activate left to activate right. And what I'm going to do is I'm going to quickly look at the motion controller pawn. And you can see here that essentially how this works is it calls grab actor on the left controller and it calls release actor on the left controller whenever these are called. If I was to open up that function, you can see that the motion controller itself just runs some quick code. So what I'm going to do is I'm going to add functionality to my hands because my body says to my hands, grab. My hands say to the object that they're trying to grab, how do I grab you? But in this case, what we're going to do instead is my body is going to say to my hands, pull the trigger. And my hands are going to say to the object, hey, they're trying to activate you. Okay? So there's a couple of different ways we can do this, but the quickest and most efficient is for me to just quickly create some new events in Blueprint that are going to be input actions. So input, what did I call it? Activate. You can see that those things that I created in the project settings, activate left and activate right, are just immediately there. And they automatically give me the options of released as well as pressed. So I've got my activate left and I've got my activate right. And I'm going to grab this reference to my left controller, which is stored here as a variable. Again, I know this is going to be the deep end for some people that are just new to this, but I feel like it's more important to show you that you can do it than exactly how to do it, so you can come back and ask me questions, and feel free to email me if you want to know how to continue further. So I've got activate, I've got a reference to my left controller, and I've got a reference to my right controller. I'm just really quickly going to go ahead and add some functionality to these cubes, so that on activate, let's just make some... On activate, let's make more cubes. That's the quickest and easiest way for us to do this. So in my cube, I'm just going to say a new event. Oh, actually, I want to put this in my interface now that I think about it. So before, remember how I said that any object can be picked up and dropped because it has a simple interface that's being added to it? Activate is probably something I would want to include in that interface because I would imagine that any object that can be picked up or dropped, I'd probably want to have a stub to have the functionality that says can be activated. So it's a rather generic function call. Does that make sense to people? Cool. I'm kind of focusing on like 2 or 3 people that are like always nodding at me and I'm like, yes. So I'm going to go here and quickly just look at the interface. You can see that any blueprint that has been added that is told to have this interface gets pick up and drop. I'm just going to quickly add a new one called activate. Compile, save. And you can see here now that if I was to click here, I can now see that event activate is a thing that exists in this cube because it has that interface enabled, okay? And upon activating, let's do this. I'm just going to spawn a new object. So the second that the activate is called on a cube, it's going to go ahead and just create another cube, okay? What's it called? Pick up cube. And the location that it's created at is going to be the same as the current cube, which means it'll be spawning it inside of itself, but in theory, the collision handling is going to sort that out and move it above. So now that we've added the functionality to the cube itself, let's quickly add that functionality to the hands and then pass that message back to our body. That makes sense? In fact, we could probably skip the hands entirely and tell the body to look at the hands and reference it that way. In fact, now that I think about it, that might be a little bit quicker for us to show you. So to do that, I'm going to open up the pawn, and activate left on call is going to call, I'm just going to say get the attached actor to the hand. And if that is valid, so is valid means check if there's actually, whoops, I double clicked it by accident. Where was I? I was in the pawn. Is valid actually checks that there's an object in the hand itself. And if that is valid, what we're going to go ahead and do is call activate on it. Okay? So I'm going to do this just very quickly with just one hand. So Jaden's only going to be able to do this with his left or right. Unfortunately, because Vive controllers are identical, you don't actually know which the left or right is until. But the advantage of how we're doing this at the moment with the motion controllers being a separate object means that the second you add functionality to one of those hands, it'll add the functionality to the other one of those hands. Does that make sense to everyone? Because it's like an identical object. So actually, I might as well just rig this up for both. Pawn. So I'm going to grab you, but instead of doing that code on the left hand, I'll just quickly tell it to do it on the right hand. Unfortunately, while the hands themselves are agnostic, the body still needs to be told if it's doing something with the left or right hand. So I'm going to launch in, going to hit play, and in theory, if he picks up an object, pulls a trigger, it's a very small cube. And if he was to like reach over and pick up one of those things, world's smallest cube, it can create even smaller cubes. The reason for this is they all have a scale that's relative. So, but does everyone see how the functionality in one thing can be immediately added to the next, to the next, to the next, to the next? You're having too much fun. But everyone can see how there's like simple setup. You're out. Okay. So, thanks, man. So you can see how that simple activate function is now in there. And if we wanted to, we could make any object that we add to the game do that. An example would be let's say I wanted to create something slightly cooler than a cube. And let's say for some strange reason I couldn't inherit from my pickup cube, so I had to create a new actor. What I'm going to do here is I'm going to go ahead and I'm going to create a sword. So a sword's going to have different functionality to a cube. And essentially what we're going to do is we're going to set one of these actors up from the ground up. So I'll show you how you would set this up, which functions you would go through, and how we could add some additional behavior to that object. Okay? But does everyone understand at the moment like how that simple activate function we could extend into any of those objects without drama? Excellent. So I'm going to right click and I'm going to create a new blueprint. Jaden, you could probably sit down for a second without too much drama. So I'm going to create a new actor. I've just right clicked, I've hit new blueprint, I'm going to create a new actor. I'm going to call this sword. And my autosave is going to kick in halfway typing it. Sword. There we go. So I've typed in sword, and when I open this up, it's just this. There's nothing in it, there's no 3D mesh, there's nothing like that. But I'm going to go ahead and go to my class settings, and I'm just going to tell you to implement an interface. And it is the pickup actor interface. Okay? If I go to my event graph in this, I can now see that if I was to type in events, I can see that event pickup is now a thing that is there, as well as event drop and event activate. So it's added that functionality to this completely new object. The next thing we're going to do is, because we want a sword, let's actually add a mesh that looks vaguely reminiscent of a sword. Typically with these presentations, I usually actually pull down some of the free assets that Epic give away online from the marketplace. I don't have internet access on this laptop right now, so we're not going to get a cool Infinity Blade sword and instead have a rectangle. Sorry, it's less flashy. This will be sword mesh. And I'm going to quickly set this up to be that. Let's kind of make this look a little bit more sword-like really quickly. So I'm going to rescale it. There you go. Look at that. What a sword. Excalibur. He who shall wield it will be the next king of England. Okay, so we've added this here as our sword. I'm also going to add a little mini handle so we can remember which way is forward on the sword. No, we can get away without a handle. So we've got a quick 3D mesh here. And if I was to hit play and get Jaden to pick this up at the moment, so I'm just going to drag my sword into the world. he's going to be quite disappointed. And the reason for that, so you can see the sword just chilling over there. Nothing's going to happen. Now the reason is futile grips. And the reason for this is we still need to add the grab functionality. Okay, so even though when we add an interface to something, it adds the stubs of logic, it doesn't carry across that logic. So we need to actually add that ourselves if we're not inheriting from something that actually had the logic in it. Okay. So a good example of when we would use interfaces is, at the moment I'm working on a project with dinosaurs. You would use an interface on a gun in the game, so I can shoot the gun, but a gun and a tiny dinosaur that I want to pick up and throw across the room is not going to have like a common parent that we really can kind of get back to. Do you know what I mean? So I would add an interface to my little Compsognathus, and now I can give it a very bad day. Because I can just add that functionality that we would have there. So do you get where I'm coming from without the common base being involved? Great. So within the sword, I'm now going to I'm just going to copy and paste these functions here. They're reasonably straightforward, so because everyone understands how it's just saying enable physics or don't enable physics. Great. So I'm going to go ahead and drop them in. In fact, I could theoretically copy those entire events, and they should copy in. Okay, now I'm going to have to, okay, cool. So all I'm going to be doing here is, at the moment, this is trying to reference static mesh component, which was an object that was in the previous thing. Instead of the static mesh component, we're now just going to, reference ourselves. Oops, sorry. Going to reference the sword mesh as the thing, and as the thing. Compile, everything works. So I told it to just make sure that the sword is the thing that's simulating physics. And now when I hit play, and he goes over to the sword, we can now have the ability to work with this object. Okay. Should have known. Okay, so that's not particularly impressive because our sword is lacking one key feature of a sword in that it's not being a sword. So let's go ahead and quickly add some extra functionality that we could tie into this object to make it cooler. So I'm going to go to my sword mesh, and there's this nice little function here called simulation generates hit events. Okay. Now, when two objects that generate hit events have this triggered, when they touch one another, they get told that they hit one another, and they trigger an event called hit. Does that make sense? Great. So I'm going to turn on hit events, and now when my sword hits something, I'm going to cut it. This is going to be the world's most basic implementation of a sword, but it'll work. So at the moment, oh, your hand's going up, or are you yawning?
Yes.
Okay.
With the hit, is there a way to get like when it's like, so you got like untouched kind of thing?
Yep.
Is there a way like to get when it's left?
When it's like released from the object?
Yeah. So like if you had like
you could.
The red pass, you find out if the red pass is still hitting.
There's a couple of ways you could do that. If you're trying to find out when it leaves an object, it's kind of a really it's a situational thing there about what constitutes leaving the hit. I would probably set that up as overlaps instead of hits, so that on end overlap. So I'd set up a tiny region that was like it goes off when something goes and touches another thing, and then the second it leaves that volume, that now no longer constitutes a hit. Do you know what I mean? So on end overlap, I would call the functionality. You can do this in a bunch of ways. Yeah, you can do this in a bunch of ways. I might actually, now that you bring that up, maybe overlap is actually a better way for us to do this. So what I'm going to do is I'm going to go back to my viewport. Swords should only cut one way, okay? So I'm actually going to go ahead and I'm going to add a little piece of functionality to the front of this sword that is going to represent the side that is sharp. So I'm going to add component. I'm going to add box collision. And I'm just going to stick this here. I'm going to quickly make it thin and only on one side. I'm not going to tell Jaden which is the cutting side, so this will get a little confusing. I might make an arrow component so we can see which side is the cutty bit. There we go. Look at that thing. So now when we look at that in the world, this is our new Excalibur. Great. So let's quickly add this functionality. Now, there's a feature that was brought into Unreal Engine in 4.13 that allows you to dynamically slice meshes. Okay? So what I'm going to go ahead and do is I'm going to grab a table that is part of the engine content. So if you see this table in the world, this table is basically my favorite thing to destroy. Half of my games that I make in prototypes involve tables coming at you aggressively. So I'm going to use this table as my reference. Now, the new functionality that was brought into Unreal uses what's called a procedural mesh tool. So it's got some functionality that's in there that allows you to slice anything that is considered a procedural mesh. And a procedural mesh is a mesh that is generated in whatever way you choose to do so. But what we're going to do is, I'm just going to give you a quick outline of what I'm going to do before I do it, is we're going to create a choppable mesh. That choppable mesh is going to have a procedural mesh in it, which is going to copy all of its information from the table, and then I'm going to cut it up, okay? This will make a little bit more sense in just a second. So I'm going to go back to my blueprints folder that I was working out of before. And I'm going to create a new blueprint. So again, this is a new thing that we're creating. And this is going to be a choppable mesh, okay? And my choppable mesh is going to have, I'm going to add a static mesh component, which is going to be called static mesh. And I'm also going to add a procedural mesh component. Now, this is one slight drawback to this system, is a procedural mesh can't be told by default what it's pulling all of its information from. So like by default, a procedural mesh is kind of like something that is ready to be molded, but you can't just tell it by default that you're going to look exactly like this. Does that make sense? Like it's not told that you will be a table in some sort of simple Dropbox. Instead, what we do is this. I'm going to do in the construction script. So before we were looking at the event graph. The event graph works by having when someone does something in the game, it triggers an event. But construction scripts are super powerful because a construction script is essentially something that runs before the game actually begins. It's when you place an object in the world, it runs a little piece of logic that determines what it should or shouldn't do. Does that make sense? So a good example is I could make a construction script that when I dropped in a fence post, it automatically built a fence to the nearest wall. And then my artists would celebrate because they would never have to manually place all of those things again. In this case, what I'm going to do is I'm going to drop in my procedural mesh and I'm going to drag off static. And I'm going to type in the word proc because this will just filter out. And you can see that there's a nice function here called copy procedural mesh from static mesh component. Okay? I click on that, and this automatically has some functionality that's just set up there to get a reference to a procedural mesh, copy all of its information into a procedural mesh, and then I'm going to hit create collision. Now, the other thing that I'm going to do is I no longer want my static mesh to exist. So I no longer want the 3D object to exist because it's there. We've copied its information into the procedural mesh, and now we want to just remove that initial one from existence because it no longer matters to me. Do you get where I'm coming from here? Great. Because otherwise we have two tables that are inside of one another, which is just ain't no fun. So what I'm going to do here is there's a cheeky way of handling this. I'm just going to say if the static mesh still exists, quickly run this code and copy the information into the procedural mesh. And upon doing so, destroy the static mesh component. This way it actually only runs it once, even if we're dragging it around, it just kind of works itself out. So now if I hit compile, save, and I was to drop this choppable mesh, oh yeah, I haven't actually told the static mesh to be a table yet. So really quickly, static mesh. Again, I don't expect people to 100% follow stuff from here. Now, there's going to be an issue when I do this, which is why I kind of want to run you through this bit. If I go table and I set this up as something that we're going to be copying data from one to the other, this is actually still not going to work. And this is the number one gotcha that's going to happen if anyone is trying to do this at home. By default, these assets don't have CPU access. So what we actually need to do is tell the table that you are something that every now and then the CPU is actually going to need to open up and get some information from. This is one of those sections of the engine that could be a little more streamlined, I'll admit, but once you know it's a checkbox that you have to fill, you don't forget because it frustrates you for 15 minutes the first time until you Google it. So I'm going to go here, allow CPU access, and now this time when I drag in my choppable mesh, you can see that we now actually have a table. But this table itself is a procedural mesh. Okay, it's not a static mesh. So they look identical. It's like, can't believe it's not table. So I'm going to delete this table so we don't get confused by what's going on. And all I'm going to do is I'm going to go back to my sword. And as I said before, I was going to use hit events, but after you asked a question, I'll show you overlaps instead. This currently overlaps everything. So all I'm going to do is in my sword, I'm going to say, actually, there's a nice way for me to do this instead. So I could right-click and I could just add the overlap myself. But one thing that's worth showing you is that if you've added any sort of component on the left-hand side to your object, you can always scroll down and you can see every single event that can be created from that component. Does that make sense? So this is a nice thing that if you don't know something exists, you can have a quick scan over this if you don't want to just type in random words to see if functionality exists. In this case, we're just going to say on component begin overlap. If the other component that we're overlapping is a procedural mesh, we're going to call slice procedural mesh. And slice just looks for two things. Slice looks for a position to slice from and a plane with which to slice. So it's trying to work out if you were cutting this way or cutting this way, because it needs that information about where that rectangle would be in 3D space. Does that make sense? So I'm quickly going to say we want to cut from where I am at the moment. And the direction that we want the slice to face is going to be the right vector of the object. So, and if you imagine an arrow, no, sorry, we use right vector. Yeah, you look confused.
I'm not sure.
Yeah, sorry. I have someone in front doubting me, which is just like making me just, yeah, what could go wrong? We might end up just cutting from the wrong direction, but I guess we'll find out. You can see that we have create other half is an option. And I'm also going to tell it to add a cap, which just means, it essentially means creates, so if you would cut a 3D model in half at any point, typically there would just be empty space where you had cut. This goes ahead and creates a nice flat surface for where the cut occurred. I'm going to tell the other half to simulate physics. This way, when it's cut, it falls off. Compile, save. Yep.
What kind of options do you have for the capping?
Oh, one other thing I'm going to do. Okay, this is also very important. Sorry, before we go into that. Now, how this works right now, and this is the danger of using an overlap, is if I was to cut, it's when something enters the box. Does that make sense to everyone? So the second something enters the box, it cuts it. What it's going to do is if it's instantly creating another half, it's going to cut that half instantaneously. Does that make sense? Because it also is now entering the box, which is then going to cut and create another half of that instantaneously. Everyone see where this conversation is going? Cool. So what I'm going to do here is there's a couple of different ways that we can do this. This is kind of like a cheap and dirty way that shows you a nice function. There's a function called do once. And all I'm going to say is only cut one time. I should probably do the do once after the procedural mesh component section, actually. All this is going to do is say do once, and after we've done the cut, I'm going to say set up a quick delay of 0.2 seconds. Hopefully no one realizes what's going on. And reset the do once. Does that make sense? Also, I can see some of you cringing because you're like, oh my god, lines are going to go everywhere. If I double click here, I can create a reroute node and clean this whole thing up. But in theory, we should be fine. Yeah, famous last words, right? Okay, so I felt the kick as it did it. Yeah. Do some more cuts. Okay, yeah. Okay, so what happened there was very simple. In the procedural mesh, you are generating overlap events. Oh, I'm sorry. I've suddenly missed something along the way. I felt the initial kick as it went through. So at times like this, it's a good idea for us to actually run debugging. I'm going to hit F9. And what F9 does is when something happens, it's going to throw on a breakpoint. Is anyone here familiar with breakpoints? Great. So there's a good chance here that I'm doing something like cutting in the wrong direction, and I've just messed up my vectors. I usually do this with a sword mesh that is... there we go. Okay, so it's doing the cut. It's doing it from where my sword is located, and it's doing it in that direction. So that's all correct. Immediately after, it's simulating physics.
Has the table got dynamic physics?
That is a good question. No, it doesn't by default. But it should have still done it off the...
Oh, where's the arrow going?
Hang on, 1 second. Yeah, okay, I see what's going on. Okay, sorry about that. So, okay, I know what's going on. We're okay now. The sword that we created, when I set things to have physics on them, I didn't make the sword mesh the base component. So when it started simulating physics, it fell off the rest of the object that was then floating in space. Like it wasn't the parent that everything had to it. So the reason he wasn't able to pick it up just then is that the sword no longer existed in that location. It was separated. Sorry about that. Now we go through again and we'll see that you should be able to pick up the sword, cut. At the moment it's, okay. So from here we go through and we quickly work out why my vector is completely and utterly wrong. And I'm sorry about that. This was something that I tested before and everything was fine. It should just fall off because it should be simulating physics. Yeah. So what I'm going to do is very simply, I'm just going to quickly tell you to, because you could be right, could be simulating physics. Sorry about this. I've run through this several times. So I've missed something this time around, I guess. Joe, you got any suggestions? Yeah. Awesome. Okay. Pick up the sword, head back. Oh. So we create the collision upon it copying all of the information to it. Say collision enabled. Collision enabled. And let's set U to use complex. Just going to do a real quick test before I put him in. Okay, this time the table doesn't fall through the world. Hey, there we go. So everyone can see the functionality that's coming in. Okay, I was getting a little bit embarrassed there for a second. So you can see this functionality, we've just added something to the world that we can tinker with in different ways. And if Jaden smacks something with the back of the sword, it won't cut unless he overlaps it too much. But does everyone understand how that's working now? So for anyone that missed those extra quick things that I had to throw in, this is how you feel about my presentation. So for everyone that missed what I did there, quickly to save that, sorry about that. I'm just going to hit escape, sorry Jaden. When I created the slice, I had to tell it, when I created the initial mesh, I had to tell it that it had to have collision turned on so it wouldn't fall through the world. Because again, procedural meshes require a little bit more setup, but you can see that you can get some really fun stuff out of this. Yeah.
Procedural mesh is what you basically use if you want to have like a vase that you smash. And
so you could do that in a couple of ways. It depends on how you want to smash the vase. You could.
So yeah, what if you want to pick up the vase? It's normal. It's all good.
Yeah.
But then you throw it and it shatters.
Yeah. Look, you could set up basic like fracture functionality. I would use this more for when I want to have a very controlled cut. So this is for when I want to like slice through something because I want to rip off Star Wars, but not tell anyone that I'm ripping off Star Wars.
So
like.
Make something a procedural mesh in order to.
Not normally, no. If you want to do like fracture effects, yeah, that's handled differently. This is for more of controlled cuts. So, yep.
Does the cut have to go all the way through it? Can it go like to a point?
At the moment, I mean, if you wanted to write something in, you could. The functionality that's built into Unreal by default just does a straight cut. So it's powerful when you use it, but it also kind of depends on how you want to use it and what the effect is. I've seen it used, I've seen this kind of stuff get used in some pretty weird and wonderful ways, like air vents that you can laser cut would be done through, it would be done through a procedural mesh, but it wouldn't be done through a, suddenly lost the word, it wouldn't be done through the slice functionality that's built in by default. You would do that on a lower level and tell it where the cuts are and which faces are getting separated. Does that make sense? Yeah, as I said, so you can see that we can really quickly and easily extend functionality. And the fact is that like Jaden suddenly has a, like when we give him something like this, VR experiences by default are actually pretty straightforward. Like you develop them in the same way that you develop your regular games with a couple of hitches. A quick thing that's actually a gotcha in VR that I'm going to point out here as well is that if I look at the VR player pawn that exists, I go back here and I look at the components, the pawn is nothing but two references to hands that exist, a camera, and an origin point for that camera. Now, here's a big issue that you're going to come across if you are using VR stuff for enemies that are hunting you, for instance. Typically, when you get the actor location of an object, you're getting its location that everything is parented from. So if I say, hey, where in the world is Jaden as an object, it would tell me where his feet are, most likely, okay? Now, here's the trick, is that while it would tell me where his feet are normally, in VR, his camera isn't locked to the center of the object. So if you think about this, the room is his location, and his head is floating around the room relative to that location. Does that make sense to everyone? So this is a really funny issue that I keep seeing in a bunch of Unreal Engine titles that are using, well, I'm not sure if it happens in Unity titles as well, it's just something that I spot because I keep seeing Unreal Engine titles, is that often if people have like really strangely performing AI, they're telling it to hunt the center of the room, but their players end up running away from the dinosaur or whatever it is, and they're a couple of meters that way, so their enemies are running this way. And all you need to do there is, if you're telling an enemy where the location of something is, tell it the camera's location instead of telling it the body's location. Does that make sense to everyone? It's just a small gotcha, but it's definitely one of those things. Now, with that said, we're coming to the end of the presentation here. So I just want to say I've been working as an evangelist around Australia, and I'm doing more sessions. So if you have any questions, you're more than welcome to contact me. Just come up and ask me for a card, I'll give you one. If you have any recommendations for sessions, any issues with your businesses that you're hoping to kind of ask some questions about and find out if UE4 is right for your team, or if VR is a good thing to get into for your project, or anything like that, just feel free to come up and talk to me. I'm happy to answer emails as well, like after the show, if you want to harass me several weeks from now, it's no problem. So yeah, come up, talk to me, let me know if as well, what you feel like your city could use. So if you would like to see some art presentations, for instance, about developing a pipeline for art for UE4, that's interesting to know. If you think that they need to have more programming tools and like discussions there, then let me know. So does anyone have any questions? Oh, sorry. The other thing that was worth pointing out was the Unreal meetups in each group. I can see Josh pointing at himself in the back. So within each city, we have Unreal Engine meetups. I think every state capital has one at the moment. The Unreal Engine meetup groups are just areas that all of the Unreal devs can kind of meet up, talk. Most recently, we had everyone that's going to be presenting at PAX Australia. We brought everyone in the Melbourne scene to kind of like compare titles and rip apart everyone's games, but in a friendly way. But that means that we were able to kind of like say, hey, this is great, but you could use effects here, 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 and here. Here's how you could add them in a painless way. Or hey, from our experience, doing this was good, but some camera lag was a really nice effect. You can do that with this. So as I said, these meetups are a great place to learn. If you're just beginning, they're fantastic. If you've been there for a while, they're still pretty useful because you think you know things and then someone will just hit you with an obscure fact that you weren't aware of or feature in the engine. So they're pretty powerful. And feel free to get in contact with Josh, who's at the back there waving his arm around. He runs the Melbourne Unreal Engine meetups. So yeah, any questions? Yep.
How would you add like a spectator camera that the computer can control?
So that's a much bigger question for, I'm happy to answer that afterwards, but essentially you would create either a pawn or a regular actor, depending on if you wanted the player to ever control it. And you would give it some basic AI that would run around. There's some super simple blueprint implementations. It would probably take me about 10 minutes to set up something that was kind of fun that you could control as well. Yep.
You spoke about movement, but you never actually showed it.
So the movement that was being used here, yeah, I'm sorry. So the standard movements that you get are looking and pressing a button to teleport to a location. So that's in the other template. All that is literally binding where you're currently looking to a function called teleport, which is built into actors. So it literally just says, here's where I am, here's where I'm going. So all you would need to do is find out what they're looking at and teleport them to that location upon a button press. In the situation that we have here with this motion controller demo that we're using, we have the functionality built into here's the update. So essentially the body goes ahead and works out a trace to a location, finds a distance, and it essentially just wherever you're aiming, it sets the world location, which is what I was talking about before. You can use either teleport functionality or set world location. The difference in there is that teleport includes your current physics. So if I use the teleport functionality while falling, I would teleport out falling at the same speed, if you get what I mean. So I could use that for like portal-like behavior, for instance. There's a couple of different ways you could do this stuff. But yeah, was there a specific question on locomotion that you wanted, like?
It was more for what's a valid location, because
Yep.
it took me a good 15 minutes to work out what's
Okay, yeah, no, that's great. So that's something that we can get into. So if I hit P, this entire world is covered in green right now. So you see how we're getting valid locations, and that was an excellent question, and I missed it. I'm sorry. So what we're essentially seeing here is that when we when we want to add AI to the world in most games, we would typically add a navmesh. And what a navmesh essentially is just an area that says AI should work out how to run around these objects. And if my navmesh actor is too small, like in this case, do you see how there's this gap here now? If I was to hit play and told Jaden can you teleport to your left? Keep going. Okay, so see how that's no longer applicable? It's not letting him in there because what's happening, sorry, I should have given you a warning before I just ripped you out. What is happening is that by default, to control the teleportation and keep it friendlier, we're using the system that's built in there for the nav mesh, which says simply, here's where the AI can go, so here's where I can go as well, and we only teleport to locations that are on the nav mesh. Does that make sense? So you'd add some volumes to your map to say these are the regions players can teleport. So that's a really good question. I mean, at the moment, if I got my nav mesh and I put it here and I hit play, hey Jaden, try teleporting. Joke's on you. But now try and teleport onto the top of those things. Yeah. So now I'm only able to go up there. So I'd move nav meshes. I can scale those as well so that if I grabbed the thing, I just keep pulling him out without giving him any warning. Okay, if I grab the thing and now hit play, he would now have the ability to traverse across both the ground and the tops. Does that make sense? So I could add a bunch of those to my map. And essentially that's what controls your locomotion and what constitutes a valid teleportation location. Yep.
Built in the sample, and what actually happens when you try to leave play space? Does any kind of grid fade in or anything like that?
When he tries to walk away? Yeah, so so how it works by default is if he tries to walk outside of the chaperone, he'll see the Steam VR grid, and he can continue walking by default. You can't see the grid. It actually only gets overlaid in the headset, which is actually really useful for when you're recording demos and stuff. You never see like visual grids and stuff popping up on screen. But those are a thing that, yeah, it's handled on that layer. So he could theoretically keep walking if you wanted. If you wanted to go further with that, you could just do a trace from the actor's location to the camera's location and always check to see whether it's uninterrupted there's no static geometry in the way. And if there was, you could then either give them a message popping up on their screen, or you could kind of dully fade it as they leave the area and go further and further out to try and persuade players to walk back into the region that they should be going in. So there's a couple of ways you would do that. If you were doing a fade like that, I'd recommend doing a fade, but with like a spherical mask around where they should be. So it'll go black until they turn around and then they can see their home. And as they walk towards that, it would be like a nice clean way to do that. You can handle that in different ways, but that's how I'd probably go about it. Any other questions? In that case, thank you very much for your time. I hope this was useful. If you have anything else, feel free to hit me up throughout the conference or PAX. I'll be roaming around. Cool. Thank you very much.